What I'm going to talk about today is essentially the demarcation between mathematics and logic in Badiou, but I'd like to explain quickly first, I guess, why I think that's important, which is that the two volumes of Being an Event are demarcated into two foundational equations, really. You have, in the first volume, mathematics equals ontology, and in the second volume, phenomenology equals logic. Now, the strange thing about these two equations is that they're essentially tripartite in their structure. You actually have ontology equals mathematics equals set theory, and phenomenology equals logic equals category theory. So, the formal structure of the two volumes and the entire architecture they employ is essentially determined by this initial choice of mechanisms, set theory and category theory, to be represented or taken as sufficient for mathematics and logic within the two volumes. Now, this fact that I take the equation in the first volume to be tripartite in this manner is perhaps not exactly controversial, but not articulated wholly in the text, because the consequence of it is that set theory is sufficient for the analysis of mathematics. Basically, because the authorization in the first volume of Being an Event is for the wager, mathematics equals ontology, and indeed the reason it's characterized as a wager is it's axiomatically upheld by a second decision, which I'm sure we're all familiar with by this point in the weekend, the whole the problematic ontology in the singular is the count as one. And so you kind of have a double structure whereby the mutually reinforcing axioms are that we ought to accept the wager ontology equals mathematics because it allows us to advance the theory of the multiple, and that the theory of the multiple and the non-being of the one as its foundation is foundational for ontology because it can be formalized as a general basis for mathematics. Now, such a position avoids circularity because it's axiomatic. Essentially, that's the way it's presented, at least in the introduction of Being an Event. And so, the key claim is that not only that set theory is important within mathematics, but that all mathematical objects and structures can be designated as pure multiplicities built in a regulated manner on the basis of the void set alone. This means that the execution of ontology as such is associated with set theory, and as such the stakes involved in approaching category theory or other rival mathematics that might potentially not be formalizable within set theoretic axiomatization are quite high. Because if there are areas of mathematics which cannot be taken by set theory, it undermines the entire axiomatic defense of positing mathematics as ontology in the first place. So this plays out in quite an interesting way throughout the Badiouian corpus, precisely following, I think, De Santi's intervention in a review in 1990, I think, where he posed to Badiou that category theory could provide a different foundational equation for mathematics. And much of what goes on in the intervening period between Being Events and Logics of Worlds, for Badiou, on the formal side at least, is an attempt to deal with this question of whether category theory can, in fact, work as a different foundational ontology for mathematics. Now, in order to get to the kind of approach where I'd like to talk about how I think he approaches this, I'm going to return to Mark and Lack and some quite general questions about formalization. So I'm just going to share my screen a second to try and get you some pictures because it's hard to do. Is this working? Can you see my slides now?
No.
No?
No.
Okay, hang on. Try again. No?
No.
Okay. These things never work that well. Hang on. That's green. Okay, try this. Now?
No.
Okay, well maybe can all skip this, it doesn't really matter so much. If anyone's familiar with Mark and Lack, I was simply going to, there's this demarcation of the box diagram that occurs where you have three mechanisms. So you have concatenation, which basically decides which marks are going to be accepted by the system. It concatenates all of the finite sequences of them into your total kind of formal space. So there's an initial demarcation from totally undifferentiated space into some kind of particular aspect of the formal that you're dealing with. Then you have a second mechanism which then divides this into which ones you can take as well and ill-formed. And then you have a third mechanism which divides those into the ones which can be posited as axioms and the ones which can then be derived from this. Gödel then shows up in Mark and Lack as the sort of problematic aporia within this, because it shows that with it, internal to mechanism 3, certain things cannot be decided whether axioms or derivable, and Badiou's statement in response to this is a strong mechanism cuts all too well. The approbation that's kind of inherent in this seems to be that there's a polemical decision in favour of the strong mechanism insofar as, in this case, forces undecidability, but it doesn't really matter. For the structure of the argument, it's that it's the forcing of decision in formal space that provides the kind of radical power of mathematics. And this plays out very strongly in how the demarcation between mathematics and logic is then played in a concept of model. So the key point in concept of model is that Badiou states that an axiom is logical if it is valid for every structure, and mathematical otherwise. So within the global space of the logical, mathematics is the inscription of a particularity. So definitionally, strong mechanisms, the ones that force a decision, are mathematical, whereas weak mechanisms, which could apply in any situation, are logical. And so he runs this through to statements, the first of which he refers to as an elementary example of a strictly mathematical statement. Now, I was going to show these on the screen, so I'll just have to try and read them. It's going to be very weird to try and do it deductively, so you just, without a board or anything, so you're just going to have to take it on faith, I guess. But you have first this formula which is some x and some y, such that it's not the case that, and then there's a lot of nested brackets, so it's hard to speak it, but it's not the case that if px then not py, then it's not the case that py px. It doesn't really matter the specifics of it, but the point is that you have two choices here. You can either choose that x and y are identified, in which case you could just substitute all of the x's for a's, and all x for b's, it doesn't matter, because a and b are going to be identified when you do the substitution. So basically, you only have one element in the universe, then it's going to scan as, it's not the case that, bracket, if PA, then not PA, close bracket, then not PA, then PA, it's false. The point is only that if you have an identification between x and y because there's only one element in the universe, the formula comes out as false. Conversely, if you choose to have two elements in your universe such that a and b are separate when you sub them into the formula can be true. So, this exemplary example of a strictly mathematical statement is taken to be mathematical because in order for it to be the case, it tells you the kind of universe to which it has to apply. And again, you then have a second formula which just does the same thing from the opposite direction. You have a formula, there is some x px such that every x is px. This is only going to be true under very specific circumstances, which namely if the predicates are absolute or void for the structure. It's very simple here. If something is something and everything is going to be that thing, it's only going to be true under the conditions that everything is that or nothing is. Again, it's taken to be mathematical because of this kind of forcing of the content of the universe to which it's going to apply. Now, this is a very strange position, I think, actually, because these formulas which are being taken as elementary examples of strictly mathematical statements, in Badiou's words, are predicate logic formulas. So what you can immediately see is that conceptual demarcations drawn from outside of mathematics completely supervene on mathematical practice, where these would be considered logical rather than mathematical. So it's the equation of mathematics and prescription that's made here is an extra mathematical thesis. And essentially we have, in contrast to a strong mechanism cuts all too well, as a support of mathematics, that logic is a weak mechanism that cuts all too little. So because logic doesn't cut, it doesn't have this kind of radical or prescriptive force, it's merely descriptive. Now, this is quite an unsatisfying position in many ways for the reasons that I've just said, which is that it doesn't seem to bear any relationship to the way that mathematics works, but also because it, as Badiou later admits very strongly, makes mathematics a limited case of the logical. So the problem you have is that mathematics would be just particular cases of a universal logical syntax, which doesn't really give Badiou what he needs in terms of the general structure of the volumes of being events. And so when he returns to look at category theory versus set theory throughout the 90s, he uses category theory as a way of avoiding this kind of aporia, while essentially maintaining the same conceptual distinction of strength versus weakness in terms of prescription. So, at the time of Briefings on Existence, which is in 1998, sometime after the initial engagement with category theory, Badiou says, real mathematics is not a mathematical inspection of possible mathematical universes. Real mathematics decides upon one universe. The upshot is that between logic and mathematics, the relation between logic and mathematics, is like the one existing between a general investigation of an ontology's logical resources and an ontological decision that entails its logical consequences. This also means that logic is definitional, whereas mathematics is axiomatic. And the way this plays out formally in terms of category theory is in the Topos lecture courses, which are from 1993, recently published in Mathematics of the Transcendental. He reconstructs an argument around the void and the function it plays in category theory to kind of demonstrate this. And now, the way that the void plays in category theory is very different from set theory, because it's not represented as a singular sign. Instead, it's represented by what's called the empty diagram, which is basically just a blank diagram with no objects placed in it, in categorical sense. But the empty diagram is the internal diagram of an object. So, internal to a category as a whole, you can have multiple empty diagrams and multiple voids that are not identical to each other. This is totally in contrast to the sort of singularity of the void as sign in set theory. And so, Badiou says, category theory renders the void itself equivocal. In contrast, however, what he then goes to show is that if you take certain decisions internal to the construction of category theory that make it resemble, and this is his word, set theory in certain important respects, then you cash back out the singularity of the void. And this is really about extensionality. So, if you think about sets, they're differentiated in terms of their members. So the set with 3 members is simply differentiated from the set with 4 members by the fact that one has 3 and the other has 4 in it. It's that addition of a 4th member in the 4th set which makes the difference. And so his language for this in the Topos course is that difference is decided in a point. Now, this is not true in all categories. However, it is the case in categories that ultimately resemble set theory in almost all other respects, including those where the void becomes singular, which is to say in categorical language you only have one empty object. So the kind of form of the proof, which then also goes on to show that in such categories you're going to have the law-excluded middle, it's going to be Boolean, is that if you set up your categories in such a way that they resemble set theory on the thesis on difference, the fact that difference is decided extensionally, then in all of the other relevant respects, void, the way the contradiction works and so forth for his theory, it's going to resemble set theory as well. So within the body of category theory, he states that within the body of category theory, set theory forcefully reasserts itself. So again, you see that it's the prescriptive force of set theory within the general logical universes of category theory that makes it mathematical, whereas it demarcates category theory as only a logic because different choices are possible internal to it. So, he ends up stating, to quote from the Topos course here, categorical formulation places ontology in an extremely open logical space, which renews its clarity within thought. Sophistry begins when we claim that the investigation of logical possibilities is itself an ontological decision, or it amounts to the same thing, when we conclude that every decision is arbitrary, or there is no ontology of truth. Now, to sort of conclude this, why is this important? I suppose it's because, for me, what it shows is that the very project of something like a set theoretical ontology is decided in advance for Badiou by a decision concerning the nature of decision. Precisely the idea that decision is prescriptive, and that then prescription in a formal space is decided on a set theoretical strong model as the measure of ontology, is absolutely necessary for all of the later demarcations which allow him to say that stuff that's going on in category theory and other forms of contemporary mathematics are simply not mathematical. But this is a strange position if what you want to do, as Badiou claims, is have mathematics as an external condition of philosophy. Because in terms of the practice of contemporary mathematics, category theory plays a much more central role in many ways than set theory does. And this is an old critique of Badiou. He addressed it in the introduction to being an event when Jean Viardon's kind of admonition of contemporary mathematical philosophers that don't deal with set theory comes up. But I think it's something that he actually really cannot adequately deal with insofar as the decision whereby set theory is ontology is never going to be mathematically articulable, and indeed it puts him in a weird position where he either has to claim that modern mathematics, in terms of its terms, the kind of geometrical formalizations of category theory, is in the grip of a regressive moment, much as with politics in the 1980s, mathematics in the 1960s has kind of ceased to have this radical, conventional break that set theory represented, or he has to claim that mathematicians in the contemporary sphere simply don't understand what they're doing. But both of these are ruinous to the idea of mathematics as external. Now, I know that this is an incredibly strong critique because I think it's a very difficult thing to deal with. But the basic question I have, I suppose, is always for anyone who wants to hold that mathematics is an external condition for philosophy, if the mathematics changes, does your theory? And this is a very difficult thing to account for. And that change can either be a factual change in how the mathematics of the period works, or it can be a change, I guess, an epistemological one in terms of how you understand the mathematics that you're utilising. But in both cases, it seems that the initial authorization of the mathematics as ontology project kind of relies on something which is articulated external to mathematical practice in a way that makes this externality of mathematics a very difficult maxim to uphold. Now, I'm going to basically stop here, but I will just point at the end towards Gilles Chapelain, who I think is a very interesting counterexample here. And over the course of the 90s, there's two reviews between Badiou and Chapelain. So Chapelain reviews Badiou and Badiou reviews Chapelain, where this plays out in very interesting fashion, because I think Badiou is essentially forced to say that Chapelain, who is himself a mathematician, and his interpretation of mathematics is misguided and essentially vitalist, because it would be actually impossible internal to Badiou's kind of axiomatization of the initial way to mathematics ontology to accept the kind of reading that Chapelain puts forward. In contrast, Chapelain critiques Badiou precisely for using set theory as a foundation for mathematics, because he thinks set theory is only a logic, and that much of what goes on interestingly contemporary to mathematics for Chapelain is unset theoretizable. So the interest of contemporary mathematics far exceeds set theoretical axiomatization. And this state becomes something that's very difficult to mathematically untangle, because if, as Badiou says, mathematics holds something of a secret of thinking or a secret of formalization, implicitly there one takes a stance on the kind of thinking that's operative within mathematics. And this seems to be a philosophical rather than a mathematical distinction. And I guess that's like, this kind of problem of externality is what I wanted to get to, and I hope that's in some way clear. Thank you.
Thank you very much, Matt. So we've got some time for questions. Anyone have any? Yeah. Matt, if you start with some sort of mathematicism that maths is crucial to metaphysics and to philosophy, then why can't maths do both? Why can't maths set theory be a decent internal model of ontology, and why can't broader maths, or maths so far, also be an external condition of that philosophy more generally?
Okay, well, answering that question in very general terms I think is difficult, but precisely what I find problematic, I suppose, in the general structure of the two modes of being an event, is that the conditions whereby the idea that mathematics is ontology can be authorized. So it's not just something that he says, oh, weakly, mathematics is interesting, we should deal with it, we should see what it can do. It's that mathematics does provide historical problems in the field of ontology, and in fact reveals ontology itself to always have been mathematics, relies upon the nested thesis that all mathematics is set theoretizable. Because only if all mathematics can be taken as a concatenation of void, multiple, and not one, essentially, is it justified to actually say that mathematics is sufficient for the entire historical discourse of ontology. Otherwise, findings in mathematics wouldn't be solutions to historical ontological problems. So it's like the retroaction of truth that's involved, this one whereby Cantor's discovery of set theory is what retroactively shows the discourse of ontology has always already been one of mathematics because it's all set theory. But the kind of acrobatics that you're then thrown into is a continual attempt to justify why it is that other kinds of mathematics that seem not set theoretizable are in fact essentially not mathematical, if that makes sense. Like, as a aporia. You seem unconvinced.
I'm thinking, man. Okay, does anyone else have any other questions or maybe responses to that point?
Just a quick question. Just a quick question to flesh things out a little bit. I mean, what would the consequences, do you think, what would the consequences for Badiou's philosophy be if you adopted category theory as the foundational model, for example? It's something that's being proposed yesterday, but not really talked about. I mean, do you think it would add anything, destroy it, or?
Well, I mean, there's two ways of answering that. Like, one is you could restart the whole project of mathematical ontology from the ground up using category theory. I mean, the problem from Badiou's perspective there is that category theory is possibilistic. I mean, category theory doesn't tell you very much. It just tells you imminently what the consequences of setting up a universe are based on the kind of initial decisions that you make. So, the problem is that it will produce multiply competing ontologies. So the kind of Greek-like searching of the matheme from the poem and all these kind of rhetorical devices that come in being an event are going to be extremely destabilized if you don't have this singularity of ontology that's forced by set theory. The second way, I mean, I don't think that makes category theory interesting, because in many ways what appears as truth in category theory is invariance. So it's invariance across different categorical models, which I mean comes into the whole thing with topoi and sheaves and all of this, that becomes the measure of truth rather than the initial foundational questions. So, like, truth is always a stitching across already constructed categories rather than like an initial searching in the beginning. I think this is an interesting view. It's also one that Badiou is probably going to be skeptical of because it seems relativistic for Badiou. The second thing is to say that you could, internal to Badiou, abandon the idea of mathematical ontology to some degree by beginning from phenomenology. So if you begin from just how it is that different things can contingently appear in categorical universes, you could have a phenomenology up view, whereby any kind of questions of like ontological transcendence or so forth are continually left on the margins. But for the same kind of way, it's not going to be really Badiouian anymore. So I think that like my initial project in doing this kind of work I've been doing was to try and ask the question, what would a Badiouian categorical ontology look like? But I increasingly think it's going to look a lot more something like you see developed in Châtelet or de Santi or possibly even some of Deleuze than Badiou. Because it's the singularity of set theory's decision that distinguishes the Badiouian project in many respects as a move.
I'm happy with that answer, yeah.
Okay, yeah, so we probably have time for another quick question. Anyone has one? You look like you have one, Michael.
Still formulating it.
Okay. Anyone? Okay, it looks like people do have questions, but it looks like they need to think about them before they give them. So yeah, I think we.
Right. Well, I'm really sorry that I can't be there to just participate in those in a more informal manner. It's a real shame. It looks like such a good space to be. If anybody wants to get in touch, they can get my details off the list. And I'd happily hear from anyone or talk to anyone. And I look forward to seeing the recordings of what went on at the rest of the workshop and being able to kind of shadow participate a little. And thank you for having me, I guess.
No problem. Yeah, I'm quite happy that things seem to have gone off without any incidents, without things that you see on like YouTube with people appearing in the back dancing. So yeah, it's very.
There's still 2 minutes, right?
Yeah, exactly. So yeah, we could always arrange that. Okay then. So with that, I think we'll say thank you to Matt.